This is the second video in a 3-video series about finding linear equations, given a parallel line. Before I can show you an example of this type, I need to develop two ideas that we're going to use in the actual example we get to later. The first idea is that lines with the same slope are parallel. Here's an example. Let's look at the graphs of these two lines. The first line has a y-intercept of 3 and a slope of 2/5, which means I can find another point on that line by just going over 5 and up 2. And knowing 2 points on the line, I know where the graph is. Now, if you're already a little uncomfortable with this kind of graphing, you may want to go back to a previous video called Linear Equations in Two Variables Graphing. Now, in terms of the second line, it has a y-intercept of -1 and also a slope of 2/5, which gives me a run and rise that lead me to this line. And as you can see, the fact that these two lines had the same slope made them parallel. By the way, the converse of this statement is also true. If two lines are parallel, then they have the same slope. If those sound like the same statement to you, let's put that aside and move on. Here's the second idea that I need to develop before we can do an actual example of finding a linear equation. It turns out you can find the slope of a line if you know its equation. For example, let's look at this. Now, if I wanted to know the slope of this line, I could go to all the trouble of graphing it and use some kind of physical properties of the steepness to determine the slope. And that wouldn't be wrong. But there's a better way to find the slope of a line if you know the equation. You can basically use pure algebra. The idea is this. If you can put this line in slope-intercept form by isolating y, you'll know the slope of this line without ever having to graph it. So now the question is, how are we going to isolate y? Well, it would be a great idea to subtract the 5x over to the other side, and then to isolate or get y by itself, it would be a great idea to divide both sides by -3. By the way, here's an algebra fact that is not very commonly known. Look at the right side of this equation where I'm dividing by -3. It turns out if you're dividing the sum of two terms by a number, that's mathematically the same as dividing each of them by that number. And that will be helpful here in reducing the equation to a more simpler form. Now dividing every term by -3 leads me to this as being the slope-intercept form of the equation I was given. In case you got a little lost in the algebra, look here. When I divide the coefficient of x by -3, I have a negative divided by a negative, which leads me to a positive. 5 divided by 3 is about 1.66, but we tend not to use decimals because approximations like that tend to mess up our equations and actually make things worse. Notice also that when I divided these, I got -4. The point being, now that I've isolated y, this number in front of it, the coefficient of x I should say, is the slope of the line, as you know from previous math problems. So, that completes idea number 2, the notion that if you're given the equation of a line, you can isolate y to find its slope. That will come up in the problem we're going to do next. Here's our situation. We want to be able to find the equation of a line if we're given two things about it. Notice the bullet points here. One, it contains a certain point and it's parallel to some other line from some equation. Now you may recall in general from a previous video that the process we go through is we graph the line, we find its slope, we then find the equation, and then put it in whatever form is specified by the problem. If you haven't watched the previous videos, that's okay, but that is the general process we followed last time. So let's start with graphing our line first. Well, we know that the line we want contains the point negative 7, 5, so there's that point. But we also know that it's parallel to this line, which I've now put as equation in red. If I were to graph that line, I would get this. The details are not discussed in this video, but again, those kind of details come from a previous video, linear equations in two variables, graphing. Now, line A is the line for whom I want the equation. And I know that that line has to pass through the black dot and be parallel to the red line. Well, there's only one line that passes through the black dot and is parallel to the red line, and that would be here. So notice it's the blue line that I'm actually looking for the equation here in this problem. That's my goal. Let's go on to find the slope of the blue line. You may recall from previous videos or mathematics that there's a slope formula. And while that's not wrong, it only works if you're given 2 points. But we don't know 2 points on the blue line. At least we weren't given 2 of them. We could find another one, but that would be cumbersome. And since we're not given 2 points on the line that we want, rather we're only given 1 point in a parallel line, it's not a great idea to try to use that formula. Instead, let's use idea number 2 that we just developed. The notion that if I know the equation of a line, I can find its slope. Well, here's what I'm going to do. I know the equation of the red line. I'm going to use that to find the slope of the red line. But guess what? Idea number 1, the slope of the red line is the slope of the blue line. And that's the logic that's going to guide me through here. Let me give you more detail. Here's the equation of the red line. I'm going to use idea number 2 to isolate y and conclude that this coefficient of x is the slope of the red line. If I went too fast on the algebra, now's a good time to hit pause and check it out. Okay, now that we know the slope of the red line, idea number 1 tells us that the blue line will also have a slope of negative 3/2. And now that I know the slope of the blue line, or line A, I can find the equation of line A. And you may recall from previous problems, we did that using this equation. This equation is called the point slope equation, by the way. Not that that matters right now. You may also recall that we would plug in certain numbers, the known slope, and recall that we would plug in the x and y coordinates of a known point on the line. And that's the process by which we have the equation. Now, if this problem didn't specify what format the answer were to be in, if it just said, find the equation of line A, I'm done. I have no other work to do. But it's unlikely that that will be the problem posed to you, because the tradition is, if you're asked for the equation of a line, you're going to be asked for it in a certain format. So you're going to have to do some algebra and convert into either slope-intercept form or standard form, depending on what the problem is requesting. And that will depend on your textbook, your web platform, your professor, whoever's giving you the problem will ask you for a certain format more than likely. Now, I haven't shown the algebra here, but I have provided the 2 solutions, or the 2 formats of the solution, I should say. And if you're feeling a little unsure of that algebra, there's very explicit detail given in a previous video called Finding Linear Equations, 2 points. That's the first of 3 videos in this series. I'd like to point out that all of the graphing was unnecessary in this problem in a pure algebraic sense. In other words, you can do these problems completely without graphing. I like to graph because it gives me a physical sense of what it is that I'm solving for. But if you were to hit pause now and follow all the algebra in this screen, you'd notice that the graph itself was never used. in determining the equation of the line I'm trying to find. Again, I like it there, but it's not required in most cases. So what have we just done? Given the description of a line, we have found the equation of that line in two different formats. Okay, you've been hit with a lot of information here. Let's summarize. You'll be given the description of a line as having a certain point and being parallel to some other line. Let's call that second line, line B. The first thing you're going to want to do is find the slope of line B by isolating y. You'll get the slope as some number. Once you find the slope of line B, you'll know that the slope of the line we want, line A, is the same as that number. You'll then use the point slope formula of a line by taking these three numbers and plugging them into these three places, doing some algebra, and converting to the form that's requested of you. And that completes the second of 3 videos.